This video is over textbook pages 18 through 21. Starting with number 17, it says the area of the top face of a cube is 9 square meters. What is the volume of the cube? So if we have a cube shape, it would look something like this. And it tells us that the top piece of the cube, so this piece that I'm shading in red, that top piece of the cube has an area of 9 square meters. We know that area is length times width. We also know that an area of the square is where we take the square root of 9. So we would multiply 3, which is the square root of 9, 3 times 3 to get our length and our width. Now, the question asks us to find the volume of the cube. Volume is found by doing length times width times height. We already know that the length and the width are 3 because that came from our area problem. And because it's a cube, the height is also 3. Because in a cube, just as a square, all sides are the same. 3 times 3 would give us 9. 9 times 3 would give us 27. We would have 27 meters cubed for our volume. For number 18, it says the length of each edge of a cube is x centimeters. If x is an integer, that means a positive or a negative number, no fractions, no decimals. Why can't the volume of the cube equal 15 centimeters cubed? So again, for the cube, and we're trying to find the volume, volume is represented by length times width times height. If we're saying that each length, width, and height is represented by the variable x, that can be represented by x times x times x. We know that the volume, or we want to know if the volume can be 15. It cannot be 15 because there's no number that multiplies 3 times to give us 15. For example, if I did 2 times 2 times 2, 2 times 2 is 4, but times 2 again would give me 8. That's less than 15. If I did the number 3, 3 times 3 is 9, times 3 again would give me 27. That's too high. 15 is right in the middle, but we've only used the numbers 2 and 3. So there's no other number that we can multiply 3 times to get 15. Number 19 says yesterday there were B milligrams of bacteria in a lab experiment. Today there are B squared milligrams of bacteria. If there are 400 milligrams today, how many milligrams of bacteria were there yesterday? So again, yesterday was B, that's our unknown. Today is B squared, which is 400. So we want to know what is B, or what can we break that down into, B times B, to get our 400 from today. Our correct answer is going to be A, 20 times 20. An easy way to solve problems like this is you multiply your numbers, 2 times 2, which gives you 4, and then we end up with 1, 2 zeros, and so we have 2 zeros in our answer, 400. So B is going to be equal to 20. 20 times 20 gives us 400. It says Eva chose B as the correct answer. How did she get that answer? The difference between A and B is that A is 20 times 20, which is the square root of 400. However, B is 400 divided by 2. B is found by taking 400 and dividing by 2. Instead, we want to take the square root of 400, which is 20. So look at the difference. The correct answer is 20 times 20, which is 400. We want those numbers to be the same, instead of 200 times 2, which is 400. Both of us give them the same answer, But for square roots, we want the numbers that we're multiplying to be the same, 20 times 20, not 200 times 2. For number 1, we have solve a to the third power, which it gives us the answer of 64. Anytime we have the exponent of a 3, we can take what is called the cubed root of 64, which means we're breaking it down into the number 3 times, which gives us 64. The correct answer is going to be 4. 4 times 4 is 16. 16 times another 4 is 64. If you chose 8, you would only need 2 8s to get to 64, but the exponent is a 3, so that is why 8 is incorrect. We need 3 4s to get 64. For number 2, it asks which number is a perfect square, meaning which number is on our list of 15. And the correct answer is going to be D, because we know that 15 times 15 equals 225. The rest of the numbers can be multiplied to get their answer, but not by the same digits as in 15 times 15. So for each of these problems, we're going to break down the fraction and try to find the smaller fraction that it starts with. So if we're doing x squared in the beginning, I want to break down 4 to the 9th power. We can break 4 down into 2 times 2. I can break 9 down into 3 times 3. And so 2/3 is our smaller fraction. For b, we have x to the third power. So I'm going to take 27 and 64 and break it down 3 times. 3 times 3 is 9, times 3 again gives me 27. 4 times 4 is 16, times 4 again gives me 64. So 3/4 is my fraction. For letter C, we have x to the second power. So we're going to break down 81 and 64 2 times. 81 can be broken down into 9 times 9. 64 can be broken down into 8 times 8. So our fraction is 9/8. And the last one, we have x to the third power. So we're going to break down the 1/8 3 times. 1 times 1 times 1 is 1. 2 times 2 is 4. Times 2 again is 8. So our fraction is 1/2. So for this problem, we're going to use the numbers in the box to fill in the square root and the answer. And then we're going to use the remaining numbers to fill in the cubed root and its answer. So the first one is going to be the square root of 36. 36 can be broken down into 6 times 6. So that is our answer. So we have used both of those pieces. For the cubed root, we're going to use the number 1,000,000. The easiest way to break that down is to break out your zeros. In the number 1,000,000, we have 6 zeros. If we split them up evenly, that would be 2 sets of 3 zeros with a 1 with both of them. 1,000 times 1,000 gives us our 1,000,000. So 1,000 is the cubed root of 1,000,000.